Hi, welcome everyone, and thank you for joining us today. I'm Anair, Chief Product Officer in Snyk, and very happy to have two key speakers joining me today. First is Sandy Carielli. Sandy?
Good afternoon, Anair. Hi, everyone.
Hi. Sandy's a Principal Analyst at Forrester, advising security and risk professionals on application security, and a person I've been talking a lot to in the last week. And Corey McNair. Corey?
Hi, Nair. Hey, Sandy. How's it going?
Great. Thanks for being here. Corey's a consultant for the Total Economic Impact practice at Forrester. One note before we get started, please note the Q&A section in the webcast panel. Feel free as we go to add your questions in. And we will work to answer as many of them as possible at the end. Really, the goal of this webinar is to have that opportunity to answer and to debate on various questions that may come from you all. So don't be shy with that. And with that, let's get started. I'll hand it over to you, Sandy.
All right, thank you, Anair. So we titled this webinar, The ROI of Open Source Security, and you can think of open source security as a pretty key component of application security overall. Why is application security an important conversation for us to be having? Well, Forrester has been asking firms who suffered a breach from an external attack, how is it you were breached? How did the attacker find their way in? And it turns out that applications are still the most common form of entry for attackers. You can see here from the stats we have that 40% of respondents said it was due to a software vulnerability. 37% of respondents said it was due to a web application issue, such as SQL injection or cross-site scripting. And those top two have been pretty consistent in Forrester's research over the last couple of years. Sometimes they've been flipped, sometimes it's been web application first and software vulnerability second, but those have consistently been the top two. And it's really telling just how much of a gap there is between number 2 and number 3. Applications are, still the most common attack vector, and that's how external attacks are being carried out. And what we're seeing as we look at software libraries and packages and images is that the problem isn't getting any better. We're still finding a large number of software vulnerabilities in open source libraries and in other areas. And Anair, I know you've done some research on this as well, and you've seen just how great a problem it is.
Yeah, definitely. Thank you, Sandy. I mean, one of the growth areas that we're seeing is really the use of open source as a driver for application modernization. Today, as you all are aware, people don't want to reinvent the wheel. We're seeing over 50% growth year over year in the number of open source modules and packages being created across the various ecosystems, be it Java, JavaScript, Go, and many others, as well as downloads. And an increase of 88% in the number of vulnerabilities in these over the last 2 years. So this space of using this infrastructure that's open source, as well as the fact that there's a growing risk with it, is something that many organizations are now very aware of. One more thing maybe to add is that with the shift to applications that you've mentioned, applications obviously are primarily owned by the developers themselves. And one interesting gap we see is that 81% of the developers believe that they should own security, but they aren't well equipped to do so. So that's kind of an important point to know, that there's a seeming gap between AppSec, as you're showing it here, and software vulnerabilities being the top threat and everybody being aware of that, but then the gap between how the developers who own the application and can fix it actually feel equipped to do so.
That's a great point, Anair, and it segues really well into our discussion of how to address this. We often talk about shifting left, about addressing security earlier and earlier in the dev process. But what does it actually mean to shift left? It's really about three aspects. We talk about security, and we have for years in terms of technology, process, and people. And you can think about shifting left from the same framework. From the technology standpoint, what is the application security tooling that you are embedding into the SDLC in order to address software vulnerabilities earlier in the life cycle? But then on the process side, what are the process and the policies that support that tooling and enable developers to integrate security into the dev process? And from the people side, what are we doing in terms of training and a broader sense of ownership? When we look first at the tooling, let's talk first about software composition analysis. You can see that there is actually a trend to implement SCA earlier in the life cycle. You can see that 37% of respondents had already implemented it in production, and only 28% are planning to do that this year. Whereas on the development side, there's a lot more investment in implementing SCA there. 37% of respondents are planning to implement software composition analysis in dev, 39% in testing, and 17% have it in their plans on the design phase. So organizations are really starting to shift left when it comes to making sure that SCA is integrated throughout their life cycle. The same thing is true on the container security side. Containers are a newer framework and a newer component for a lot of applications. And you might think that security is baked in, but we know that's not the case. What we're seeing, which is very promising here, is that organizations realize that, and they're starting to implement the container security tooling throughout the life cycle. Even though only 17% of organizations had already implemented container security, you have another 20% that are planning to do that in the design phase this year. Even though only 33% had implemented it in the development phase, you have another 37% planning to do this. So again, there's a lot of focus on addressing container security issues earlier and earlier in the life cycle. And Anair, I know you've looked a lot at the security of containers and container images, and have a pretty good sense of why this is such an important issue.
Yeah, I mean, we came with that same assumption that moving to containers in a new platform, like you mentioned before, it would be more baked in when it comes to security. The reality is we've done some research, and the top 10 most popular Docker images in Docker Hub, which is probably the most popular container Docker image registry, each contain at least 30 vulnerabilities.
Wow.
So yeah, so many of those are containing Linux distributions and middleware that is very vulnerable. And one of the things that we're also seeing throughout is that from the thousands of scans that we're doing at Snyk, over 70% of them are ones that, if the developers would take some action of upgrading the version of the Linux OS or one of those things that they're using, they could have a significantly more secure image. So the fact is that currently out there, most images are very vulnerable, and many of them are not really being taken care of in organizations today.
So this is really something that organizations have to pay attention to. And in fact, it is one of the key steps in securing containers during the software delivery lifecycle. What's telling with container security is that it's not just a single step, and it's not just something you do in production or something you just do in development. It's a series of steps throughout the life cycle. And it does start with that using trusted images, but it also comes down to reducing clutter, making sure you're using the right set of images and that they are clean. And then you get into some of the governance of operations on the production side, where it really comes down to being able to respond to vulnerabilities in containers and container images, and managing some of the scanning as well. So it's a series of steps throughout the life cycle that needs to be considered and addressed by organizations. And it can be time consuming, can't it?
Yeah, definitely. I mean, it's one of the things that we're seeing today, sadly, when we come into organizations with containers, is that basically they give up. So many of them are kind of seeing containers that have dozens and sometimes hundreds of vulnerabilities each. Very hard to understand what those vulnerabilities exactly are on, if it's some shared object library. And they rely on trying to catch anomaly behaviors at runtime in order to know whether something is potentially being compromised, but not really knowing what to do in order to make those images more secure. And one of those things that I think you pointed out very well, the how it's important to do this throughout the life cycle. And shifting left obviously was discussed previously. One very interesting thing about containers is that it fundamentally changed the way machines are being defined today. Think about the good old days 5, 6, 7 years ago when 5, 6, 7 years ago when in order to get a machine, what you would do is you'd open some ticket and someone from IT would use some golden image, spin it off, and they would own 100% of the patching of it, etc. Today, a container, for efficiency and all the efficiencies and agilities it enables, is defined by developers. There's some Docker file, some definition file that sits in their Git, and now they need to remember to upgrade the patch version of the operating system, right? So, so it fundamentally moves the ownership from being only kind of IT and into the right, also to the left, where the developers now own having it and fixing it.
I am
So I think
so glad you said the word ownership there, Anair. That's a really critical element as we're, as we move from talking about tools to talking about some of the process and the people elements of shifting left, addressing that sense of ownership by the dev team and making sure that the security team is enabling them and enabling security in a very seamless, frictionless way in their build cycle is really critical to help development take that sense of ownership. The worst thing we could do from a security standpoint is to add a lot of heavy process that's going to block the dev team. The dev team is incented to get product out the door. And so we need to make sure that as we're introducing security tooling and process, that we are not creating any blockers in there, that we're not, as the picture here shows, we're not bringing an axe to a hockey game, and that we are really speaking the same language here. And, when we talk about ownership, there's a story I like to tell. I've heard it told, various versions of it. But the gist of it is there was a community and they were looking to have a large celebration in a few months. And they wanted to make sure that they had enough wine for that celebration. So the townspeople all agreed that every week, every household would bring a goblet of wine into the center of town, and they would pour their goblet of wine into a large barrel. And if everybody did that, the barrel was going to fill with wine so that in a few months, when this grand celebration occurred, they would be able to open up the barrel and have plenty of wine. Well, the first week, one local townsperson comes in dutifully with his goblet of wine, and as he's pouring it in, he realizes, well, nobody can see what's in my goblet. Why should I waste all of my wine for this? I can just bring in water. I will quietly dump in water. Everyone else will have wine. And so, yes, maybe there'll be a little bit of wine in the barrel, but nobody will note a little bit of water in the barrel, but nobody will notice because there's so much wine in here. Why do I have to take responsibility or ownership here? So lo and behold, what do you think happened in there?
Well, I'm not sure everybody got the proper happiness going in the celebration eventually.
Well put. The celebration comes up, they open the barrel, there's a small layer of wine and a lot of water because everyone else was relying on someone else to do the work, relying on somebody else to bring the wine. And you can see that with open source security, sometimes there's a similar risk, that there's an assumption that somebody else is taking ownership, somebody else is making it secure. Or with container security, the assumption that you talked about earlier, that these were coming in as a secured framework, as secured components. And we know that that's not the case. So knowing that our assumptions that somebody else is securing this are incorrect, how can we help developers take ownership here? And by the way, this isn't something that we can blame the developers for. Fact is, developers aren't really trained in security. We looked at the top 40 computer science programs as ranked by US News and World Reports. Right now, none of those top ranked programs in the US require a class about secure coding or secure application design. So we are forcing development teams to learn this much later in their careers and really as they go. And so the challenge that we have is to find ways to turn developers into security people and do that without adding a bunch of security process on top. So this is where we come to meeting developers where they are, where we come to making sure that we are not restricting the speed of development, but that we are enabling them to become security people, to learn security concepts, to fix bugs, to address security issues, and do that in a very efficient way that aligns with their existing process. So what does that mean in terms of shifting left then? At the top, yes, we want to implement security tooling earlier in the software development lifecycle. And we've seen trends towards that. I think we still need to see more, but we're definitely moving in that direction. Meeting developers where they are to drive ownership, making sure that they are comfortable with the tooling, getting them engaged in the buying process even, so that they have some insight and some influence in the purchase decisions. Assigning developer security champions is another area where there can be a lot of value. Getting developers engaged with the security team so that developers know who to talk to on the security side about different issues, but also so that other developers know who within the development team they can ask questions of and who they can engage in. Anair, I know that some of your customers have had some success with security champions types of programs. Do you want to speak to that a bit?
Yeah, thanks, Andy. So first of all, I think this whole area is the $1 million question, right? How do we help? We all understand that the only way to scale security, like you're saying, is to have security embedded as part of the dev and DevOps process, DevSecOps, etc. In order for it to be efficient, in order for it to happen all the time, and not have just a small folks, AppSec folks, trying to run after the herds of developers that are pushing code daily and hourly. And the key question is how do we do that? How do we do that well? How do we do that in a collaborative way? So just two examples that come to mind. One is one of our customers, Assurian. They had a program around having security mavens. So having select people that they would coach from application security and kind of be those owners of it, but not only owners in the sense that they're the only ones owning it, but rather they were the ones that the team could come and ask questions. They were the one promoting the team around it, and that was something that was kind of celebrated in the team. One thing that's by the way, talking about celebrations, and you mentioned that wine celebration before. One of the things about celebrations is that usually security is not about celebrating, right? Usually security is about blame, and that's part of what nobody wants to do. Security, it's all about blame, right? So it's a good thing about how do you turn security to also be a celebration, right? And another customer we have is the Skyscanner, and what Skyscanner did is they created leaderboards with all the teams, taking data from Snyk and actually from another tool or tools in other areas of AppSec, and kind of had just leaderboards of who is the leading team in the sense of how many vulnerabilities are they fixing. And suddenly taking ownership on security becomes a positive thing that developers are doing versus a fear-mongering blame game. So I just think that these are maybe two type of kind of insights into the type of processes that you can put in place on top of tools that are working well and that are developer friendly in order to kind of achieve a culture that could embrace security within developers.
That's a great point, Anair, and I love the concept of making security a celebration. You're right. Too often we do blaming or shaming around security, even though, as we pointed out, we're not always providing the training early on. But if we make security something that is incentivized and rewarded, rather than something that people are blamed for, then we're helping to enable that greater sense of ownership. And if we're able to embed some of the training even within the SDLC, so it's not an add-on, it's not just somebody sitting through something for a day, but it's really built into their daily life, they're going to build that greater sense of ownership. So Corey, I know you have some thoughts on ROI and some of the rewards of building security into the SDLC. I'll turn it over to you now to talk about some of the findings that you had.
Thanks, Sandy. So Forrester's total economic impact. Our team has a long history of helping companies quantify the benefits and of the technologies that they offer. And I led a study on Snyk's platform, and I'm happy to be here today to talk to you about these findings. So just to, as a quick note, this presentation is an abridged version of a complete case study. And the case study is informed by an extensive Forrester interview with a Snyk customer. Snyk provided introductions to its customer. However, as an independent third party, Forrester had full control over the content included in this case study. So on this next slide, you can see the TEI methodology that has been in place at Forrester for over 20 years. We've used it to evaluate the impact of many different technologies and solutions. So it's a very flexible framework that can be applied in a lot of different situations. It consists of 4 main areas. We look at benefits and costs. This is fairly straightforward. Costs are things like licensing costs or implementation costs, and benefits are the impact on the business. We also look at flexibility options for the future, and we view all these through the lens of risk. So we risk adjust every category to arrive at the total economic impact. Now, just to jump ahead, I'll review our high-level findings. Prior to using Snyk, the interviewed organization that we talked to felt that security at their organization was at risk for 2 key reasons. They did not have a security solution in place, and the security team conducted manual vulnerability reviews on its digital infrastructures. After adopting Snyk, the interviewee said their organization resolved these issues through automating the delivery of intelligence on high security threats, faster vulnerability remediation, and integrations into existing developer tools and workflows. So just to jump ahead, the customer experienced a 340% return on their investment in Snyk over a 3-year period with a net present value of over $1.5 million. And now I'll share the details of how we derived this ROI. For the study, Forrester interviewed a Snyk customer based in the technology industry, located in North America with over 267 million in annual revenue. The tech vendor handles millions of pieces of sensitive information from other organizations, has used Snyk for over 2 years and has over 250 security engineers. They also are using the server to host Snyk Broker, a proxy between Snyk and on-prem hosted repositories. And some other key categories for the organization to search for a security solution included manual analysis of their networks. This led to a general oversight in vulnerabilities and unpreparedness for threats. There was also a lack of detailed threat reporting, which led to slow remediation timing. In terms of requirements that they were looking for from their chosen security solution, the organization wanted to provide automated intelligence for high-level security threats. They also wanted for the solution to work well with existing development tools and workflows. In addition, they wanted the solution to provide dashboards and seamless notification to the project owners. Some of their key results since adopting Snyk included that Snyk was able to be integrated with internal platforms and automate open source vulnerability scanning, and the security teams became more confident in the consistency of the vulnerability reporting. In this case study, which you can review after this webinar, it includes candid quotes from the customer, such as the one you see here, and should give you a good idea about their experience with Snyk. Now, in terms of the top benefits, The interviewed customer described 3 primary benefits from using Snyk, the most significant being a reduced risk of a cyber breach. They also experienced incremental savings from the automated filing of tickets on vulnerabilities, and savings from reduced time spent investigating and remediating vulnerabilities. I will go into the details of the 3 largest benefits in turn and explain how we've modeled these into our composite organization. Before Snyk, the organization primarily tracked major security threats through news reports of threats. Any other vulnerabilities were caught through manual reviews of their infrastructure. The interviewee specifically cited the 2017 breach of Equifax as a cause for alarm at their organization, and that they need to become more agile to avoid a similar scenario. Since adopting Snyk, the security team's concern over a cyber breach decreased, noting that it has been especially helpful to the organization in recognizing threats such as external entity injections and cross-site scripting. The numbers here reflect estimates over 3 years, where we quantified the value of this benefit by assuming the following. For the organization, the average cost of a data breach was $5 million. Since adopting Snyk, the organization was able to cut its risk of a data breach in half, from 30% to 15%. The solution helped specifically to resolve at least twice as many vulnerabilities than before in a 1-year time frame. This is largely driven by improved threat monitoring across key product lines, and there was also less lag time from when the team discovers a threat to when the developers fix it. We apply a 20% risk adjustment to make the analysis conservative. This results in a $1.6 million value over 3 years. And just as a note, the slides here share the highlights from the study, but the full calculation tables can be found in the study itself. The second benefit here speaks to security researchers avoiding spending time on each ticket filed for vulnerabilities. Snyk itself automates the process of filing tickets for threats. Without Snyk, researchers at the organization would spend roughly 15 minutes copying down threat details and then spend an additional half hour on validating the threat. Validation often required several emails being sent back and forth between researchers for details. Snyk effectively eliminated all the time spent on that task. We quantified the value of this benefit by assuming the following. Across the 3 years, there are over 1,600 vulnerabilities recorded, of which each take about 45 minutes to write and file a ticket for. We assume the average hourly rate for security researchers is $46. And of the time savings realized, we assume that workers capture 70% of the productivity to rededicate toward additional work-based materials. Again, we applied a 20% risk adjustment to keep the analysis conservative. Now, in another form of time savings, Snyk helps to provide time savings in the form of avoided time spent investigating and remediating vulnerabilities. Previously, when a ticket was filed, it was only as detailed as how much visibility security researchers had into their system's infrastructure. Manual filing would also lead to the occasional human error with the wrong information copied down, which would then lead to additional time spent on investigating and remediating the vulnerability. The interviewee reported that Snyk helped developers to do a lot less research, with tickets providing all of the necessary details. They specifically called out Snyk's internal database on vulnerabilities, as well as identifying vulnerabilities that would have otherwise been missed if they only followed the National Vulnerability Database. We quantified the value of this benefit by assuming, again, across 3 years, there are over 1,600 vulnerabilities recorded, of which it would take 8 hours to investigate and remediate each one. We assumed the average hourly rate for developers is $57. And of the time savings realized, we assume that developers capture 70% to, again, rededicate toward additional security-related tasks. We also then applied a 20% risk adjustment to keep the analysis conservative. This resulted in $350,000 savings over 3 years. Now, moving on to unquantified benefits. These are key benefits that couldn't be quantified for this study. Based on the interview, Snyk's flexibility for integrations with existing development technologies in the tech stack was a key benefit, and that Snyk helped to build confidence in the organization with security information to act on. Now, altogether, for a company similar to our composite organization, we expect these results that you see here. And just to speak briefly on the cost, the customer spent some time during deployment with integrating with other applications and inputting scripts for identifying vulnerabilities. The interviewed organization also pays for Snyk based on the number of developers given access to the solution, totaling around $60,000 a year annually for that company. In summary, altogether with the benefits and the cost, we expect a 340% return on investment, and it holds over $1.5 million in net present value, along with a payback occurring under 3 months. Before I transition in there, I just want to make a quick note of disclosures that you can view here in the webinar deck. But now I hand you back over to Anair.
Thanks, everyone. Hope you all got all these great stats and you kind of have it all in your heads right now. So coming back, some of these stats I threw out there beforehand on the amount of open source that's code. One interesting bit is to understand how much of your code today in a modern app is really open source. So I think there's an animation there. So one of the things is, maybe not, so we can go back. So one of the things that we're seeing is that most of the code is open source code. I just had their example of a, oh, here it is. An example, so this is a Java simple app in a Spring app that what it does is like a grocery, you can add milk, add something, products, delete them, buy them, etc. Very simple web app, REST API, database, very standard. If you look at its dependencies, then what you see is that it has 7 dependencies. Maybe the ones with you with great eyes here could see, REST and JDBC for database and all those things. So there's 7 dependencies here, 7 packages I'm using for my code. These 7 packages in turn use another 59 packages, so totaling 66 packages. 59 of them I'm not even aware I'm using, but they were kind of brought in once the compilation happened, and overall totaling over 700,000 lines of code. So this is just to show you how in most of the apps, as you can see we just released a report on Java right now, and you can see that most of the applications written out there right now are written in Spring. So these type of frameworks. So the lion's share of code that you're running is open source, and most of it you're not even aware you're running. An interesting stat here is that 78% of the vulnerabilities are actually on those transitive dependencies, the indirect ones that are being pulled in. So this is just to give a picture on why this is really just an example of why this is such a prominent issue, and how really understanding exactly what you're using and how is not an easy task, and definitely needs to get some aid from automation all around. Obviously, there's a stat here of the 2x doubling of vulnerabilities. So that's kind of around the one more step into the problem of open source vulnerabilities, how it looks like. So when we talk about shifting left, as kind of Sandy and myself did before, there's a great question of, okay, we talk about the need for dev first tooling and the fact that it enables collaboration, but what are the real pains in how that's seen? So we can see that most developers, and there's a nice animation here as well. So we can see that most developers believe that they should actually own security, but they're not equipped to do so. And on the other side, on the security bits, many feel that security is a major constraint on their ability to deliver. So security is still seen as a blocker in many cases, and many of the developers want to take ownership, but don't feel they have the right tools. So that's really what the solution should address. The solution should be one that enables developers to move quickly and have security embedded in, on one hand, and on the other hand, empowering developers with tools that they will actually like. So this is kind of when we started Snyk. This was in our mission. So Snyk is really about developer first security, focusing on enabling and empowering organizations, developers and security professionals to develop fast while staying secure. not having this contradiction of do you need to develop fast and insecurely, or be secure but put many just stop signs in the advancement of development. One of the interesting stats I like to show here, so we said we're focusing on open source containers. You can see here a few of our customers, but one of the interesting stats I like here is the 400,000 users. So one of the things around Snyk is that we have a fully working freemium. So I would actually recommend that any one of you just try Snyk out and see just what it looks like. We've done that from day one, so there's a significant investment in having developers, just developers out there, to actually want to use the tool for open source. And we have hundreds of new users coming in without any marketing budget or anything of that sort, and using Snyk to scan their own repositories. Sometimes it's their own private projects, sometimes it's projects from their own small companies, sometimes from the bigger companies. But having this connection, direct connection to the community, is where we found that it really helps us stay true to building a product that's usable enough to cater for one that would be that developers would like. If we really need to think about three things that are needed to focus on in order to answer this problem in a good way, then the first one is empowering developers. We talked about that, and we'll get sooner a little more into that, how you, like Sandy showed before, embed this into the life cycle, and only if developers embrace it, then it scales. Automating fixing is very, very important. So many security tools out there are ones that produce reports, and those reports, you can pin them to the wall, and you can provide the reports and stats for your boss. But at the end of the day, when the question comes of let's look at the last 6 months and see how many issues we actually fix and what reduction in the risk we were actually able to achieve, it's pretty low. So that tool needs to be very actionable. And at the end of the day, it's you're as good as your security. So if we look at empowering developers, just to take a deeper dive into the SDLC and kind of putting names into those, code. So as developers are coding in their IDE, in their CLI, that they have their direct feedback on what open source they're using that has vulnerabilities, or on their container images, in their Git, making sure that no new code that's being developed is put in that's vulnerable, making sure that the build itself, to being able to put some gates so that it's not being deployed if it's insecure, etc. So really making sure that you're on the right in order to put the right gates in place, and you're on the left to prevent adding vulnerabilities and to help developers fix as soon as possible. If we're going towards the next phase of automating remediation, so how does that happen? So one of the interesting bits about automating remediation, in the next slide, is around doing this calculation. And sometimes it's hard. We discussed before about all these transitive dependencies, indirect ones. We need to map and build this whole tree and then calculate what minimal changes need to happen in the direct dependencies that can also affect all the rest. So there's a lot of logic, and at the end of the day, produce automation for it. So just as an example, at part of kind of the dev first mindset, right? If a new vulnerability is discovered today, discovered today, a developer that maybe has never seen Snyk, never heard of Snyk, will come to their office tomorrow and open their repository in their Git and see a code change pull request waiting for them from Snyk with the minimal upgrade that they need to do in order to change their code, to fix the vulnerability. So that's really how we're trying to be as proactive as possible, as integrated into the tools as possible, and as automating as possible. And lastly, which we said was around the database. So won't go in depth here, but just to say there's no really great one place where all the vulnerabilities exist in a very timely manner and well curated with the exact versions that are vulnerable and content, etc. It's a very hard work that's done by a large security team that looks into many sources, brings them all from all of them, enriches them with data, finds itself. Last year we disclosed over 50 vulnerabilities ourselves from our own research, finding them quickly because we listen on all the Jira and GitHub projects. So anytime someone opens there an issue and says, hey, maybe there's a security vulnerability there, it would get to one of our analysts. So, and well, there's a few partners here and the likes. So I think that if I need to sum it up of this section, which is kind of, okay, we said we need a dev first and an automated tool. This was really about what Snyk took the approach of implementing that. So what are the main principles of that implementation? So being well embedded into the dev SDLC and being throughout it, from when someone's coding to when someone's pushing something to production and running it there, making sure you have all the right feedback within the native tools is key. Making sure that you're automating remediation, so fixing is easy, so taking an action on the findings is something that doesn't have a large overhead, and having kind of accurate and elaborate security data is complementary to that. So I think with that, would love you all to take another few seconds and write a few questions. Oh, I now see we already have a few questions. So first question. What blockers are companies facing when looking to implement this approach to security? How are they going about resolving them? Sandy, you want to take this one?
One of the things that we talked about early on is the engagement with the dev team. And I've had conversations with some organizations that are, looking to move more deeply into DevSecOps, that are looking to embed a lot of this into their organization, but they haven't yet engaged with the dev team, or the dev team, isn't fully aware of what's going on. And so one of the things that can sometimes stop a project before it starts is if you don't have the right people in the room. When I do workshops, we always insist on having representatives from one or two of the fastest moving dev teams in the room, because they'll be the ones who can map out what's the process, where are the potential blockers, what do we have to address in order to make all of this work together. So it's really important to have all of the right stakeholders engaged from day one.
Yep, I think we're seeing something very similar. If all we have in the room is just the AppSec person, and they they didn't get the buy-in from the developers, and they haven't tried it out, they're not in the mindset for that, and it's more about us versus them, then usually that's a hard blocker. So there's a lot of kind of trying to bring it to be a one team type of effort that usually helps. And what we try to help these companies do is, we would try to pull them into the POC phase. We have a full developer relations group that would go and actually give talks and kind of, in various talks over pizza and beer in various of those companies, and a few more offerings that really try to bring out that kind of we're in this together feel.
Yeah, it's really important to have the developers involved in some of the purchasing decisions for tooling and really engaged from the beginning.
Thanks, Andy. Next question. How do you remediate a vulnerability in a widely used Docker Hub image? So maybe I'll take this one. So that's a great question. First of all, the fact that it's widely used doesn't mean it's necessarily a latest version of it. So that's one thing, to look at which tag you're using in it. And the second is, usually you need to strip it down. So usually you need to, instead of using a Node, for example, image that's one of the top popular ones, look at one that runs Node Slim. Or many of those have other distributions, other images that are running similar capabilities, but are kind of much more slimmer. So you need to be smart about looking at not just taking the first thing you're seeing as a base image, which may be including much more than you actually need, but rather being much more accurate in your needs, and therefore taking the time to choose the base image that's right for you. Snyk, as an example, one of the things we're doing in our container security product is we're giving base image recommendations. So we would look at all your vulnerabilities that came from a certain image that you're using and recommend to you which similar close image you could use that is less vulnerable. So I hope that one helped. Let's take this one. Do you have more? So maybe that's for you, Carrie. Do you have more info about the calculation of the numbers? So how we got to some of those calculations?
Yeah, so it's a combination of what we heard from the interviewee and their internal measurements. So some of the key KPIs that they spoke to, it's just really centered around that speed of fix. So the length of exposure time and where it was before adopting Snyk, and then where it was after, and how much they've improved on that, and what areas it took place in. And as I went over, a lot of it was with the ticket writing, and then also the time of applying to fixing the vulnerability. So we take what we hear from the interview, and then we also go back, and I went back and forth with Sandy to get some of her feedback to apply some of the more accepted industry assumptions. What's realistic here? They reported that they're seeing this much time savings and stuff. Does that align with what we're hearing? And then so we try to couch that and ground that in our own internal research to really kind of come up with those numbers.
Great. Let's take another one. Which team do you recommend to handle the container security vulnerabilities? Developers or infra team, and why? So maybe Sandy, you want to take a first crack at it?
This is an opportunity to really embed this into the development lifecycle. If the developers are the ones who are spinning up containers, who are building applications and working, pulling in the images, it becomes a pretty natural part of their process to be able to address the vulnerabilities at the same time. So in terms of creating a frictionless, a more seamless experience, giving the developers ownership can be pretty powerful.
Yeah, I totally agree. I think that what we're seeing in most of our kind of more forward-looking companies is that at the end of the day, the ones that can fix a container vulnerability are the developers. They're the ones that need to go and change some of their config code to upgrade or to change some of their machine definitions. So that's kind of an important to the why, right? The infra team, at the end of the day, they can't fix. They can block, they can kill a container, they can do a lot of, you know, direct things, but they can't go and fix an image. So, and probably the infra team don't need to be out of the picture, the infra and security teams, they still need to be in the governance side, but what you really want to do in order to scale it over time is like Sandy's suggesting, is to embed this as be something that developers do as part of their process. In order to adjust the severity of SEA, does Snyk provide some services of security policies in the SDLC? Okay, so I'll take this one as it sounds a little Snyk specific. So yeah, there's policies today where you can adjust vulnerabilities. You can say you want to ignore a certain vulnerability for a certain reason. You can't handle it right now. You don't think in the environment, for example, if you have a denial of service vulnerability in an internal service, then you know that the risk of denial of service in internal service is really not something that you're worried about. So you can ignore that. You can change its severities. So we're enabling some of this, plus various guidelines on what we, for you, in various configurations on what you can use to put gates. So you can define that a build would break if it has a critical severity. So these are the type of things you can configure, and policies is something that, well, in pricing mode, it's kind of in more of our enterprise tiering, obviously, and it's something that we're actually actively extending and expanding right now as we speak to make this even more flexible. Okay, I'm seeing some of the last ones seem to be really oriented a little more to Snyk, so I'll take a few more of those. What tooling for code bases, e.g. scripting for audits on adding dependencies in a node-based code base, IDEs, CI, Jenkins are available for use right now that we can plug in. So, go into our docs and our website. There's also already an IDE for IntelliJ, and Eclipse, VS Code is coming. Jenkins has a plugin. There's also CLI that you can use and put it as a build step in any CI tools. So yeah, adding dependencies in node code base. Again, you'll have a Git integration so that anytime something is added to your code base, it'll be scanned. So I think that you'll see that you can easily plug in. Another one that came in was what the pricing model. So one of the things that's actually important for us is we price by developer. So we price based on the amount of, at the end of the day, the value we deliver is we secure the outcomes and the work of a developer building an app. And we want to have our pricing model aligned with the value we're providing. So the pricing model is based on the amount of contributing developers to the projects that we're protecting. But again, there's also a freemium that has kind of slightly limited use, and it comes to the amount of testing it has. So we can't use it now on 1,000 projects or 100 projects, but it has all the basic functionality in case you want to play with it as well. Does Snyk provide API for getting notation of security scan on an open source library? So yes, there's APIs today. You can again see the links from the documentation. API wise, we're also open today for paying customers, mainly because there's a few more guards we need to put on the API before we open it to everyone. How does Snyk detect and report vulnerabilities that don't have a CVE? How do you make sure it's a real vulnerability? That's a great question. So there's, as said, there's a few ones that are non-CVE, and there are quite a lot of them that are non-CV, and where do they come from? So they come from various sources. Some of them are ones that, as said, we research and look at ones that are kind of threads and discussions that are happening on Jira and GitHub projects of specific packages, are ones that we research ourselves. In some cases, there's also a vulnerability in some known database, but just nobody filed a CVE. Happens a lot in places like Node, for example. Node in JavaScript, only a small percent of the overall vulnerabilities, even ones that exist in various public databases, have a CVE. So these are all ways in which Snyk connects and gathers all these who don't have a CVE. We have analysts looking into the fact that it's a real vulnerability, and we work with the maintainers in order to disclose them in a responsible way. Even the ones who have CVE, again, CVE has very limited data on it, and one that needs to be highly enriched. So with that, after doing exactly 10 questions, I think we're, oh, do we have more questions popping up? No, I think we need to stop at 10. So I think, unfortunately, we're out of time right now. So there's quite a few Snyk product questions that I see that are coming in again, like the few ones that I took later. So we'll have a follow-up in the next few hours to make sure you all have the answers for that. And feel free again to trying us out and to contacting us and to kind of looking us through. I want to say a really big thank you to Sandy and Corey for sharing the high-level market insights of the trends that we're seeing, as well as how value of a solution like Snyk could be calculated. So thanks a lot, Sandy, and thanks a lot, Corey.
Thank you, Anair.
Thanks, Anair.
Great.